So we appreciate that delta H mixing may be a more complicated thing to try to figure out, and it may vary without our ability to make a whole lot of insightful predictions about it. But delta S mixing is something that is not going to be difficult to understand at all. Here's a picture here that shows fundamentally what happens when you talk about delta X of mixing. Here are two different materials. There is a pure version here and a pure version here. Now I have to ask, if I were to mix them and create this mixed version here, which one is the one that occurs naturally? Which is the one that tends to happen? Which one is the one that drives something happening? Well, this is the second law of thermodynamics in action. This is the idea that delta S of the universe has to increase. So as I look at this process here and ask, in general, what would I argue would be the case for the sign of delta S of mixing? Well, you can see here that it's going to be positive as I move in this way, in this direction. Whether I'm making more particles because I'm dissolving salt into water, or whether I'm simply making things messier, I can be comfortable that mixing is a good thing. It's a driving force for a reaction being spontaneous, for a process being spontaneous. And then, in general, delta S of mixing is going to be positive when things happen. This allows me to rule out the cases of delta S being negative and focus on the ones where it's positive. In that case, then, there really are only two possibilities. One is that with delta S being positive, delta H is negative, in which case the process always happens, or delta H is positive, in which case it's going to be a temperature-dependent result. So as I look at the different examples coming up, that's what I'm going to want to keep in mind. That this being negative is what makes something happen, that this value here is what tends to happen when mixing occurs and is therefore positive. And then my issue is with figuring out what delta H is.